Alright, what's going on, guys? First off, I just want to apologize. I've been away, I've been working on some things and researching some devices, so hopefully I can get some of those videos out soon. I think they're pretty cool, and I think you guys will like them. But today's video, we're looking at this Govee LED strip. You can see here, it's got Bluetooth, and it's got an app. I'm just going to go through how I approach these kind of things so that you guys can kind of understand my methodology. So, first off, the first thing you want to do is use the device how it's intended, right? Connect to the device with your phone, iPad, Android, whatever you're going to use to control this. Connect to it, mess around with it, see what inputs you can put into it, and how maybe you can leverage those inputs to mess with the device or alter the device's state. Since I've already done that and I don't really feel like showing that because it's going to be just me clicking around and changing colors on an LED light, we can go to the next step, which is like discovery. So here we can use just a simple scan. We're going to use HCI tool to do LE scan, which is a Bluetooth low energy scan. And you need to run it as root and make sure your Bluetooth adapter is plugged in. Once we do that, we can see we have the Govee device, right? This is the Govee device we've been looking at, and we're just going to want to copy this MAC address. Now from here, we have a few options. You could also discover it with your mobile app, mobile phone, using the NRF Connect app. I actually really like that and almost prefer it over this. It's easier to use, and I mean, your phone is really quick and easy to just pull up and start scanning for devices, and it allows you to connect with the device right there and even send characteristics, send data, and you can mess with the device that way. You can actually use that as a mobile app to interact with like ESP32s and stuff. So we can look at that later on in a separate video. But what I want to do here now is we could start an interactive session with GATTool, and we'll connect to the device, right? It's going to attempt to connect. Hopefully it will connect. Sometimes it doesn't. And in our case, it does not look like it's going to connect. So what we can do here, exit, and we can do this. This usually helps. All right, well that didn't work either. So let's try this command. I forgot the third T. So tac B will set the address. Tac T random, and then we do tac I. And now we were able to connect. So as you can see, we use tac T random, which helped us connect. We can try it. I don't think it'll allow us to connect without this. Yeah, it doesn't appear to. So yeah, we're just going to use the random flag option, whatever you want to call it, and we'll connect to this device, right? So once we connect to it, we can start enumerating it. So we can like look at characteristics. We have all of these characteristics, but nobody really wants to do this. This is a pain, and it's going to disconnect you occasionally because we're not sending like keep alive messages. So what we can do instead is use BetterCap. BetterCap is actually a great tool that I use for Bluetooth hacking all the time. So here is the command I'm going to run. This is just running a Docker container with BetterCap. And here we have BetterCap. And so we have our options, right? You can see BetterCap is really capable of doing quite a lot. But what we're most interested in is BLE Recon. So we're going to do BLE Recon on to start scanning for the device. Then once we find our device, we'll do BLE.enum, and then we'll give it the, well, I need to get the MAC address. So once we grab the MAC address, ble.enum, and now it's going to attempt to connect. Now this is exactly what we want here, because this is really what we're going to look at, right? So we see all our handles over here, characteristics, and the properties. The properties that are going to be the most important and what we're going to focus on the most are going to be these write properties. So anything that has write in it is going to be what we're looking to interact with. So like the device name, I mean, we could try to change the device name. That might be cool to do, but it's really not that effective. We want to control this device. That's what we're aiming for. The appearance of the device doesn't really matter that much either. But then down here, we have this write and this read, write, and notify. So these are going to be more interesting, and we're going to want to take note of these handles because this is what we're going to use to communicate to the device when we use GATTool. So keeping these in mind, we can go ahead and capture the traffic when this device connects to my mobile phone and how it interacts. And we're going to be looking for write requests that are sent to one of these handles. It has to be sent to one of these handles because this is where it is able to be written to. So when we see which handle is being written to, we're going to use that. And we also have to see what data is being sent and how that data is being set up. So to do that, we're going to use Wireshark, and we're going to use an NRF. It's called the NRF 52840 dongle. It's a really cheap Bluetooth dongle that you can find online. You can just, what did I say it was? A 52840. So yeah, this, it's 10 bucks. Get it, and then you're going to have to do a little bit of work. You're going to have to, it's called, it says program it, but you pretty much have to drag and drop some files and flash it to this, and then it'll be ready for sniffing. Then you have to configure Wireshark for that. And then once we do that, we can open up Wireshark. Okay, so yeah, once you plug in this dongle, we can go to Wireshark and we'll actually see that we have the option of a Bluetooth sniffer. Maybe we need to make sure it's plugged in and make sure our interface is refreshed, and now you can see the sniffer. So I like to have my device ready because we're going to want to connect to it when it's pairing and see how that pairing process goes. And as you can see up here, we have this different interface that's not normal with Wireshark. So this is going to allow us to, we're going to be able to filter out by a certain MAC address, and it's listening to these advertisements, these channels for Bluetooth. So these are the advertising channels. So it's listening on these three channels to see what devices are advertising. We don't really need to mess with any of these. This is the thing we're going to mess with so that we can select the device we're looking for and just filter out all the noise. So all advertising devices, we see our Gobi device. And now if we connect to the device where it should, all right, well, it failed this time. So this happens sometimes. You're just going to have to restart the capture and go through the pairing process again. So on the app, we're just going to delete the device, forget the device, and we're going to reconnect to it. And now this time we got what we wanted. So we put it into pairing mode, it pairs, we're leaving the name, whatever it is. Now let's send a few commands to turn on the device. So when we stop this capture, which we'll do now, ignore that. You can see some of these write commands, right? We have a sent write command, and if we look at the attributes, it's a write command. So if you guys looked at my last video, we were looking at write requests. So I don't know, this says write command, this says write request. Because in the info it says write request, we're just going to use this as a filter. And now we can see all the write commands that were sent. So we sent it on and off a few times. So we're going to look for that pattern, right? Something that was sent quite a few times. And I mean, these 3, 3, 0, and then 32 have been sent a few times, but we're not going to know which one it is until we try it. Now we can use that get tool command that we were using to connect earlier to connect to this device. Grab the Mac there, and then T random and tac I so we get an interactive one. So now, okay, so I grabbed my phone and I'm currently recording a video of the device. You'll be able to see it down here. So what we're going to do is we're going to connect back to the device like we did, and we're going to send the command. And as you can see, lights up blue. So now what we can do is we can look for the off command, which should be somewhat after it. So this one is similar, but it's 3-2. So that one's pretty easy. Let's just switch the 3-3 to a 3-2. We'll connect and we'll try it. And that one didn't work. So what about this A01? What if we copy this value and we'll try this one? So this is what, like Bluetooth low energy hacking, there's a lot of trial and error in it, especially with the replay attack. Okay, but anyway, you guys understand the process. That's what I went through. I don't think you guys want to sit through and watch me try a bunch of random values, but this is how I figured out what values send what data, right? And control what things on the device. So because it is a light strip, we can also send colors, right? We can change the colors on the device. So here is just some Python code I wrote. So this is using Streamlit, which is a Python library which allows you to host your Python code as like a web page, and PyGat. So we were using GatTool. This is a library that allows you to use GatTool from Python. If you guys want, I could put this on a GitHub so you guys can take a look at it and you guys can use it yourself. You would have to change the MAC address to make sure that it works for your device, but you guys can expand upon this and use the method I showed you guys to make like a Bluetooth light changing app or web app that then you can control without having to use Govee mobile app, because who knows what they're doing with that mobile app, and why do that when this is a lot cooler. But as you see here, we had to convert things to bytes, and to handle the data that way, here we have the connection function, where it's just connecting to the MAC address, and it's looking for this characteristic. Then it stops the adapter, which it does after it connects. But when it sends a command, the first thing we need to do is the checksum. So maybe it's something I'll go over in the next video because the video is getting a little bit long. But to send these values, and I actually wish I still had actually I have them here. So you can see here, right? This is the on command and this is the off command. So I believe it just uses an XOR checksum. I could be wrong. But right on, we have 330101 and then 33. And then for off, we have 3301 and then 32. So we can assume, I forget what this was called, but these four pretty much always stay the same, right? For sending an on-off command. Then we can assume this 01, This turns the device on. This 00 turns it off. But since we have this extra one, we end up having 33 versus 32. So these last two digits back here are the checksum. So you need to calculate the checksum, and as you can see here, we're going to need to calculate it for each different color. Another thing we need to do was get the hex and the hex format for the color, so we can get the from hex, and we convert that for the bytes, and then we generate the checksum, and then I actually have like a color picker. I'll show you guys what this looks like. And then we put together the color string, we add the checksum, so we use the checksum calc, which is this command, and then we return the command. This is the full command with the color string and the string's checksum. And then somewhere sends the command. I don't remember exactly. But I hope you guys have a gist of how this works. I could put it on a GitHub if you guys want, and you'll be able to look at it more in depth. But if I go to, yeah, this one. If I just exit out of here, just make it a little bit bigger. But if I just run Streamlit, run, and then the name of it, I called it Gobi Web App. You'll see we have this like web app. Okay, embarrassingly, I had the device unplugged. I accidentally unplugged it with my chair. But as you can see, we have this beautiful interface, and we can change the color, right? And it takes a little bit, but you will be able to see the color does change. You do have some errors. This code isn't perfect, but it works. You'll see the color once I click off of it, send the command, and the color will change after a little bit. Change it to any color on the spectrum because it's pretty much the colors it handles. And it does this all automatically. It's converting the hexadecimals, the color hexadecimal and stuff. So I think this is pretty cool. This is something you guys can definitely do. Set up on your own computer. All you need is a Bluetooth adapter and this device. And yeah, you guys could just probably just change the MAC address. But I challenge you to build it out yourself, make it better than this. This is obviously not perfect, and I haven't worked on this in a while, but it is pretty cool that we can control the device without needing to use the mobile app. So in that case, stay ethical and try to hack everything.